All right, so let's talk about arrays. So arrays, as you will see, is a list. Okay, and this is a list or a collection of related items. Again, this is only applies to Visual Basic. Okay, so it is not true in other languages. Like for example, in PHP or JavaScript, it's not true. When I say it's not true, we're talking about the similar items. Okay, because Visual Basic is a strongly typed, right? Strictly typed language. That means that the data type has to be the same, right? So we learned that if you declare a variable called name, and if you set that to be a string type, then it can only hold string data type. You cannot suddenly change it to numbers. The same thing applies to arrays. If you declare an array to store a list of items, then those items have to be the same type. You can't say this array holds, your student name, student ID, student phone number, and things like that. Okay, only one type, either all strings, all integers, or all Boolean, and so on. Okay, but it is a list or a collection of data. Array is also sometimes referred to as a reference type, versus the variables we use so far up to this point are simple type. Simple meaning that if you declare a variable, again name, as a string, then that variable can only store one data type or one data, right? It cannot store 2 or 3 or 4 different types of data. I mean the same data type, but you cannot store 2 or 3 names there. Okay, whereas an array is a list, so it can hold a lot of data of the same type. So if you think of an array as a bucket you can put a lot of candies in there, right? All kinds of candies. Whereas as a variable name is just a one candy type. You cannot have multiple candies inside one candy. So typically, for example, you think of a grocery list, that is an array, right? You store eggs, bread, ice cream. All these are the same data type. So they're all strings, okay, or foods in this case, but strings. Also, like on Facebook, right? Your friends, Facebook. These all like names. Again, still strings. Contains only related items, okay. And or on a midterm scores for students, right? So you have a list of numbers. It will be either a double type or decimal numbers. Okay, you cannot mix them with other data type. Or price of items in your shopping cart. Again, deals with data types of decimal places, numbers. So again, for example, your grocery list, your friends list, and you can solve these. Well, not solving, but it just said a list. If there's no list in your cart, then you can add items to your cart, right? So you can add eggs and milk and so on. And if you have a list already, then you can do a lot of things with that list. You can check your list, what items you have in there, how many items you have, what is the do you have eggs in there, do you have bread, and so on. If it's a list of friends, do you have John in there, is Joe in there in the list or not? If it's not, gonna add it to the list, right? And you can also delete items from the list as well. So in terms of numbers, you have a list of scores, and we have used a list before in a list box. Okay, you've seen that before, but a list box is a little bit different from an array because a list box can shrink and grow, right? If you remember, we delete data from a list box. You can add to the list, and it keeps growing, or you can delete it, keeps shrinking automatically for you. With an array, it doesn't do that. Array comes with a fixed size. Okay, if you have 10 items, then you are only limited to 10 items. You cannot go more than that. You can go less if you choose to, which is fine, but you cannot go beyond that limit. Okay. So in this example, you have a list of scores, and with this score, you can, on a shopping cart, you can do some data manipulation with those numbers. You can, for example, find the highest score, which we did last time, kind of similar to what we did with the list box. The highest numbers, the lowest numbers. You can get the average of these numbers. Find the median, which is the middle number, and then all sorts of stuff with those numbers. Okay, so Price is the same thing, right? You can look for the most expensive item in the list, the cheapest item, how many items have the same cost, and then of course you also get the total bill of that cost and so on. How many items are more than a certain price range. You can do all sorts of stuff with that list. Okay. So for example, here is a flow chart just to find the average of 5 numbers, any 5 numbers input from the user, right? So you can do begin, get the sum, then you go through a loop. So this loop has a counter, right? This will be counted from 1 to 5. So the first iteration, you will read the input from the user, get a number, you add that to the sum, and then you keep doing that 5 times, and then you get the average. You just sum divided by the number or count, which is 5, then you get the average, right? So this is a very simple, typical loop to find the average. Over here is another very simple one, although it's really tedious work and also not very efficient. But this is how you would, I guess, read numbers. Okay. Like read 5 numbers, and then you print those numbers in reverse. Okay, so you read the first number. So that means that you would declare a variable name first, and 1 second, 1 third, 4th, and 5th, and so on. You read each number in that order, and then you just output it back in the reverse order. You get the reverse order of that, right? In a very simple sequential order. If you have that many numbers, it's not a big deal. But imagine if you have 100 numbers or 1,000, right? How do you do that, right? So with that in mind, then array becomes the best candidate to store those data, okay? Because once you store those data in an array, like in a bucket, then you can now sort those data in any fashion. You can print them out. You can choose just to print any number of data out, only one or all of them, or just half. It doesn't really matter what you do. Okay, you have the full bucket of data to do with. So input is a list of number. For example, the sum is just the average. Find the sum average of the numbers. We did something like this, for example. The sum will be, if you add them up, you get 22. Average is divided by 4, you get 5.5, right? Pretty simple. If you can also find the largest number, 3784 is 8. And then the question is, do we have to keep or to remember the entire list of the input numbers while we solve these problems? What do you think? If you want to find out the largest number in the list, or find out the average of that list, do we have to remember all the numbers in the list? Yes, right? You have to know those numbers. Otherwise, how do you keep track of which is largest, which is smallest? Okay, so that means that you have to have an input to store number 3, one to store number 7, one to store 8, one to store 4, and so on. So you can have 4 variables. We call those simple variables to store each number, and then you can compare each number, right, or each variable one by one to find the largest number, or you can add them all and then get the average, or you could use an array to store those numbers in a single variable, and that way it's much easier to maintain. So what do we need to remember at any point in the solution? Well, this is a little bit it depends what you're looking for. So for example, if you look at the largest number, then we need to track the current number or the last largest number, and then you compare that with the current number, right? If you move down the list. So so reverse number, if you have that input over there, I showed you the little simple flowchart how to print them in reverse order. You just basically you read in that order, and then you output it in the opposite direction, and you get the reverse order out of that. If you were to store like those in separate variables, that could be done, but it's not really efficient. And again, the best way is to put them into an array. You can also sort them in increasing order or decreasing order. You do that easily with arrays, whereas if you store those into separate variables, that could be quite difficult. And you can also find the middle number and so on. So I want to go into, this is another, this is something different. I'll go right into the definition of the array. Okay, so here again, array is a variable. Just like any variable you use so far, you can create an array called names, and then and usually because arrays are collections of multiple items, multiple data, the names is usually a plural. Okay, so you have cities, array of names, students, classes, and so on. Whereas if you were to store in a single element, then usually we call it, you use a single word, right? Like a student or name, age, phone number, and so on. But arrays, because it stores a lot of data, the convention is to use plurals. You don't have to, but it's just, again, by convention. So array is a collection of data that has a name, just like variable names. Each of the values in the array is called an element, okay? Element of the array. And then each element is like a separate variable. So inside that element or the box is it's a number, or it's a string, it's a character, it's a object, okay? And you can modify those values as well, just like you would you can treat each of those elements just like a variable. You can change its value, delete it, and so on. And each element is identified by an integer value called the index, or the subscript of the array. Okay, so when I say index, it's always referred to the position of that character or the number in the array. This is the same idea with the strings. Okay, so string also has an index number, right? Index position from the 0th position to the end position of that string. Okay, the array is the same thing. You have an index or the subscript to track each element in the array, and then the index are always integers. Okay, it cannot be a string or a double or a decimal number. Okay, it's always integer from 0 to n, and the lowest index is 0. Okay, then you have an empty array. There's no well, actually 0 position is the first index, and then you have the largest index is the maximum index you can set to an array, and that is called the upper bound. Okay, so when I say upper bound, it's always the maximum index for the array. Okay, the position, not the length. The length is different, right? The length is same as a string. The length could be like 5 characters long, but the upper bound is 4. Okay, so it's always one less. This is only true for Visual Basic. It's not true in other language, like Java, for example. If you put an index of 4, that is the maximum character of that, which is the index position. So to refer to an array element, you have to use the name of the array followed by a pair of parentheses, and then inside that parentheses you put the position number. That can be a constant number, or you can use a variable name that would store the index number of the array. Again, it has to be integer type. It cannot be other type. So, for example, if there's a num of arrays contains a lot of numbers, then you will put that position here. If my array, the number 2 means the 3rd position, okay, because you're counting 0, 1, and 2. So that is the 3rd position, but index of 2, just like string when you did your assignment. So this is something else. This is different. This is the logic, visual logic. So I'm done with this one here, and I'm going to move on to the other slide, the one in the book, and it will be kind of similar. So chapter 7, it deals with 4 topics. So the creating and using arrays, we'll do that. Link, I think we're going to skip that for now. Maybe we'll revisit that again in chapter 10 or chapter 9 when we deal with the database. Okay, because the link is we'll see if you have time. If not, we'll talk about that later. because LINQ is just very similar to SQL. If you know database, that's the language you use to retrieve data from a list. The arrays of structures. Again, we'll talk about section 3 and 4 next week. Structures are a type of array which is the precursor to object-oriented programming. I mentioned to you that arrays are usually in Visual Basic, it's a collection of the same items, right? Same data type. Okay, so if you're using structures, we'll deal with that next week again. Structure is a type of array that can store multiple type of data. You can have different types of data in a structure. You can have strings and objects and numbers and so on. And that is the only way you can create an array with multiple data type. And then we'll deal with 2 dimensions as well next week. So, so this is the same thing we just talked about. Here is an example of how you would want to store some scores, right? Like student scores. So you have 3 students, and each of the students have their own score. So normally you would declare 3 variables called student 0, student 1, student 2 as string type. So the name of that student, and then plus the score will be like the double type. Okay. Let me see, I'm just do something really quick. I just wonder why it's not showing the other screen over there too, so you can see them. Let's see if that'll fix it. Oh, it's coming on. Okay. Sorry about that, I didn't realize that. So you can see that you can have 3 variables to store the student names, and then 3 of those other variables to score their data, right? Which is fine in this case. You know, 3 is not that big of a deal. So, so to do an easier way to do this is you will create 2 variables, and then those will be arrays. One will be like maybe students, okay, to store the student names. And then you can have another variable of arrays called scores to store the scores. Okay, just make sure you're matching the index numbers between the student and the score. And we'll talk about this type of arrays next time also, which is called the parallel arrays. So you have 2 or 3 arrays because so you cannot have an array that stores students, which is a string, and their score as a double type. You cannot put it in the same array, so you have to separate them out. And if you do that, then you have to also track the index number. They have to match the index, right? Otherwise you have the wrong score. So student 0 will have the score of in the score 0 index, and student 1 would match the score 1 index, and so on. So that's called parallel arrays because they work in parallel. And of course you can store like student names, scores, their IDs, their address, and so on. Okay, so you can have multiple arrays. So here's how you will declare an array. Okay, so for example, I will declare students of 29. Okay, so that 29 is the upper bound, which is the subscripts of the array. Okay, so that is the maximum index for that array. That means it will go from 0 to 29. Okay, so that's the index. And then same thing with the scores, right? So scores will be from 0 to 29, so you have a total of 30 students. Okay, so that is the upper bound, which is the maximum subscript, but the total length of that list is actually 30. We're including 0. Okay, so it will be so if I ask you to declare a array of students of 15 students, then you will put dim students paren 14, okay, because including the 0. Okay, if you put 15 there, that's incorrect. Again, that is the opposite of Java. Java, if you put a number 39 or 29 there, that means that has that many students, which is kind of confusing in either way. It's just that in Visual Basic, that is the maximum number you can go up to, and the index. And Java is just the reverse. It will be -1 from there. So just lots to remember. And then again, you have two separate variables, two separate arrays with the same number of index, so I can reference the same index position, and I will get the correct score from the, from that student. And if there's any errors, then that'll be just human error if you incorrectly put the score in there. Otherwise, if you code it correctly, then they should match up with that same index of I, for example. Okay. And so yeah, very similar to how you would declare a variable name, except you put the paren right in front, right after the word of that variable name, students or scores. As soon as you do that, okay, if you declare this way, notice that I'm not assigning any values to the students or the scores arrays yet. So if you do it like this way, then you have to put a number in there. You have to give the limit, like 29 or 3 or 4 or something. You cannot just leave it blank. Okay, this is one of the rules. And then how you assign values to that position is now you would say students of 0. It's always and how you say is like subscript 0, right? Students sub 0 equals Tom Brown. Then that will be assigned to the position of 0 in the array. And then if you want to go to the next list, next item will be just again students 1 and so on. This is very similar to the list box we did last time. So here is the just the general syntax for declaring an array. You use again the word dim, the name of the array, followed by the n, which is the upper bound of the array, and then you have the data type. Okay, 0 is the lower bound, and every array is always lower bound is always 0. You cannot just suddenly start from 5 to 10. Okay, it's always from 0. This is true for every language. Okay, but in some languages you don't have to. You don't have to use 0. You could, like for example, in PHP, I could just suddenly say, array name at the 110th position and put some value there right away. But you cannot do that in Visual Basic. You have to declare the number of the upper bound first before you can use any position in between. Okay. So n is the upper bound, 0 is the lower bound. The number of elements is always n plus 1. So again, this number inside here plus 1 gives you the length or the size of the array. So here is an example for example, if you want to find Super Bowl team, I guess the winning team Super Bowl, from just ask the user to enter a number between 1 and 4, and it's supposed to give you the number of the players or the team that won Super Bowl. So for example, here you have a array of team names. Again, by convention is always plural, okay, because have a lot of teams, of 3. So again, this 3 is the max index, so really it's a team of 4. Okay, count will be 4, and then you would dim n as the integer. So n will be the really it will be the actual counter here. So you would assign team 0 Packers and Jets and Chiefs and so on. N is to count. Well, you get this from the form field, right? Dot text. So you get that from here. This number here. You read a number from here to n, and then you just basically pull the team n minus 1 to get the correct number. So for example, if you put 2 here as the input, the second team, the second position is really the index of what? 1, right? So that's why you need to reduce it by 1. So 2 minus 1 to get 1 to correctly select the team here, team 2, because we don't have to concern about 0. Okay, so again, depending on how you set up your application. And so if you put 2, right, you get Packers out of that. This one here, the load event procedure, I think we talked about this last time also, about the mybase.load. This is usually you use it in the form to kind of like initialize your form, your application. and it only runs one time, right? Once you load the application, you run it, it would, first thing is to load this method here, the subroutine here. It's set up, you can set up the initialization here, load anything that you need to load before your application starts. And this only runs one time, so even, it's not going to go back and reset it again. It just runs it once. And this is a good place to really assign values to arrays, or set up any default values to your list or your page, okay, before you do anything else. So for example, you could set your arrays dynamically this way without having to set it elsewhere. So when you load the application, it will load the mybase.load, and then it will then set up your array team names with these default values. Then after that, then it will just wait for an event, or a click event in this case. And then because we set the dim team names as a global variable, right, it's outside of a subroutine, then this can be accessed anywhere else in your code. That's why down here in the second subroutine down here, we can access the team names directly from within the subroutine because it's in global space. If you put this inside the sub here, then it won't be accessible from here, so it will have an error. Okay, so that's very useful. Just make sure you if you use that, that'll be useful. If you don't remember, to do that, I think that's, again, that's optional, but usually that's the case. Not just for Visual Basic, and in every language you always want to initialize your values. Okay, so here I show you another way how you can set up arrays. So one way is, you notice that you declared an array of teams named 3 as a string. You're not assigning any values yet. How do you populate? The word is populate the array. How do you initialize it with data? Is you will go, and here it says team 0, Packers team 1, Packers team 2, 3, and 4, all the way to n, whatever that index is. If you have 100, you do it 100 times. So you can imagine how tedious that could be, right? This is one way to do that. Another way is you would do it this way. You can assign the values right away as you declare the array. Okay, so if you do it this way, then you cannot put the number in here anymore. Okay, you cannot put the upper bound inside the paren. You have to leave that out, because now the upper bound is determined by the number of elements you add to that array. So for example, here you can do it this way. Team names, just put a paren here. The paren tells the program that this is an array of type strings. And how do we know how many elements are there? Well, that would depend on the values you put over here. So if you put only 1, right, it will be an index of 0. Okay. If you put Packers and Packers 2, only 2 items here, then the length of that will be 2, but the index will be just 1. Okay, so you don't specify the index here. It will be determined by this the values you have here implicitly by the program. Okay. Okay, text files, we'll talk about this next time. The reason why we use text files is important, because text file, you can have all these data in the text file line by line, and you can actually read the text to database, to the Visual Studio, and it will actually copy every line by line to an array, and the array will automatically generate a list for you like this. So if you create, like, for example, dim team names as string, and if you read a text file to this team names, then depending on how many lines of text inside the text file will be automatically generated and added to your database, the array name here, and then it will also, because we don't specify the limit here, whatever that size from the text file will be automatically calculated for you. So for example, if you have a text file has these numbers in there, right? So these scores, so 1, 2, 3, 4, 5, 6, 7, 8 items in here. So you have an index of 7. Okay. So when you create you add this to your array, it's going to have an index of 7, and you have a maximum count of 8. And so, for example, if I were to say IO, mean input output dot file dot read all the lines from the text file called ages at inaugural dot text, then it's going to add those lists here line by line. Each line here is called a record, right? A record is an element that can be stored inside an array. So this will be the first position, which is position 0, position 1, 2, 3, and so on. And then the array will be automatically generated this index for you. And so you have a list of 8 items. And then now, and then you can access those data inside the array. This is another one. So you have a list of 44 people here. Would be like, in this case, would be like presidents. And you get the ages from the list here, assuming that there are like 44 items in this list. So from 0 to 43, you get the ages printed to the screen or added to the ages array from this text file. Okay, and these are some built-in array functions that you can use in your array. You can use this to find the number of elements in the array is by using the element name, array name .count, that will count the number of elements. Kind of same thing with a string, right? String that length give you that. If you want to know the maximum or the highest value inside the array, then just array name .max. .min is the opposite. The lowest value that applies to both numbers and characters or words, right? Words are use the ASCII code number. You add all the ASCII code number together, you get the highest value. If you want to get the first element, of course, that first is always the 0th index position. The last is just the last position. If you don't know, the last element, you always say, array name .last, give you that last number. If you have like 1,000,000 in the array, you don't know what the length is, just put that last will give you that very last element. So a quicker way, I guess, to say array name paren 1,000,000, right? So the upper bound of the array is you can get it in 2 ways. Okay, one is use the .count, and then you -1. Okay, assuming that if you don't know the count of the element, like for example here, we read the ages inaugural.text to the array of str ages. You don't know how many items in the array, so how do you find that out? Versus here, if I do the ages 43, I know exactly what that is. That means it has 44 items, has the max or the upper bound index of 43. I can see that, right? But the ages we don't know. So to find that out, you could use the .count to tell you. And you again, you just have to subtract 1 to get the max index. If you want to know how many elements in there, just put .count. It will tell you it has 8 or has 100. The index is -1. Okay, the upper bound, and the lower bound is always 0. So here again, that first is same as the sub-0. You can also get the average of that array, assuming if they have numbers. So it's all calculated for you automatically, which is pretty good, right? You don't have to do that manually yourself. You can do that, which we did already last time with the list box. Same idea. You add them up, each one at a time. Do the total count. Divide by the count, you get the average. But it has a built-in function called average, and that will spit out the average for you. Same thing with the sum. Okay, this because it's so common that they just built this in there for you. Okay, so the average, the sum, the minimum, the maximum, the count, and all those are all available for you to use. So again, these are built in for you, available for you to use already. So we know that the maximum, the minimum, we can get that easily, but just do the .max, .min. But how would you do it if you were to use a loop to get those numbers, and without using the method in there? How would you get that, right? So you have to iterate through the array from the 0th index all the way to the n index, and you have to compare each value one at a time, and then you would save that to a separate variable just to track the largest number or the lowest number, or whichever you want to look for, and you compare each one of them. And if it's larger than the one you currently have, update that, and you move on to the next one, right, until the end of that list. Okay. Again, this is not true for, so these shortcuts here, the average, the sum, the max, and the min, all these are not true for every language. Okay, so for example, Java doesn't have this, right? So you have to figure out yourself, and other languages do not have them either, so you have to do that yourself. So that means that you have to know how to compare elements and get the average, get the sum, and get the largest or smallest number, and count how many numbers are the same, and all those cool stuff. So you could use the for next loop to examine or look at each element of the array and then compare the value. Okay. You can also use the do loop, do while loop, or the while loop, and so on. Again, with the for next loop is because you know exactly what the element size, so you know that this array has 10 elements or so on. You can do that. So it's usually more common to use the for loop than the do or the while, and plus you have less code to type. Okay, you don't have to create a counter, a separate counter, and you just have, sometimes you might forget to update your counter, and you have an infinite loop, which we saw. We did that last time. It caused a problem. So with the for loop, you don't have to worry about that at all. So here is how you would get the number, right? If you want to get the maximum number, okay, assuming that we're not using the dot max. If you do this, it's pretty easy. You just say ages dot max. That will give you the maximum value, which is 69. Or if you do ages dot min, give you the smallest number, which is, in this case, will be 46, right? 46. But if you were to loop that in an array, loop the array, and then check each value yourself, then you have to do it this way. Okay, so you assume that your max, you have to start somewhere, right? You just assume that the max, or the largest number is the first element. Okay, it doesn't have to be the zero position. It could be anything. You just set that up. You just say 0, it's fine, right? But since you're doing an array, you could pick the first element and assume that that is the largest number. Okay? And then you loop through the array. As you can see, it says from I as integer equal to 1 through ages count minus 1. Right, so you have 9 precedents, and you want to go just the index of 8, because we're using I inside the counter here, which is the index, which is the subscript. You don't want to go to 9. If you go to 9, you have an error, which is the out of bounds error. Okay, so always, again, minus 1. So notice that we also don't check 0. So usually we'll say index from 0 to ages count minus 1. But since we already assigned 0 to the max, right, you don't need to check that again. We just assume that we'll move from the next number, which is 56 here, and then we'll compare this with our current value, and then update it that way. So if the first index here, the 1, 56 is larger than the current max, which is 55. If that is true, then now we update that, and we will switch it to be 56 now, and you move on to the next list. And then you go to 61, all the way to the end of the list. In the end, we'll find that 69 is the max of the list. Okay. To do the min will be just the opposite. Same thing, right? We would just set the first element to be the smallest number, and then here we would just, instead of greater than max, we would say less than max, right? If it's less than max, then we'll update that, make that the smallest number, and then in the end we'll get that 46 will be the smallest number. Okay, so pretty typical way of how you can find the max and the min using a loop instead of the built-in functions. Any questions on these arrays? How this is set up? And so again, this is the other way how you can initialize the array. It's quite common, much quicker, okay, than you would do it line by line. So you can't, once you do this, of course you can always override these values too. So it doesn't mean that once I set up this way, then these numbers are fixed. Okay, it doesn't mean that these cannot be changed anymore. You can change them anytime you want. Okay, so after this line, for example, down here, if I want to change the age to the index of 0 to be 53 instead of 55, I would just say ages paren 0 equals 53, and that replaces the 55. Okay, so redem, we'll talk about this later. Redem means you can also resize the array. I'm just going to skip that. Okay, so the other loop is the for each loop here. So here, just kind of show you what the differences are between the for loop. This is the for next loop on the top, and then the bottom is the for each loop. Okay, so the syntax is a little bit different. Up here, we deal with the index position, right? So we say for the I as the index, the counter, also the index, from 1 to the count minus 1. Really, we should really say 0, but this is, I think this is from the previous example. Assume that we want to iterate through the entire array, then usually we say from 0 to ages count minus 1, and then we compare, so we get the data in the array by using the array name, and then paren with the subscript to get the value, to read the value, and we have to increment that value every time by 1. So here we don't see it, but usually at the end of this, here is a step, right? The step parameter, which is step 1, which is plus 1 every time. And then now this is the for each loop here. Everything in blue here are keywords, which just means they are required, right? So instead of saying for I as integer, you can say for each age. This is a variable name. You can call it whatever you want. For each A, for each B, for each person's age, doesn't matter. This is just a variable name, and then you declare that as the integer type. In this case, because this type here has to match the data type declared for this array, because array of ages contains integer. So we are going to loop through this array, and we'll say for each age, right, inside the array, for each element, same thing, in the array. Then now we can access each element in the array using this new variable here. Okay, and then we don't have to specify the index like we do up here. Right, this is called the actual array with the index. Here we are actually using a different element parameter or variable to represent the each of the elements inside the ages array, and we'll do that from the 0 index all the way to the end of that array. Okay, so you don't have to worry about counting. You don't have to worry about the index number of the array. It doesn't really care. It would do from 0 all the way to the end. If that's your purpose, then this is the best way to go. Okay, if you just want to print everything in the array, or if you want to compare to every element in the array, then the for each is the fastest way, and also the easiest way to write, because you don't have to worry about the index. Okay, the only thing is with this is that you cannot modify the array because you don't know where it is. You don't know the position. Up here, for example, if I want to change ages of I to something else, I can. Right? So if ages is greater than max, then I would say ages is assigned to max, but I can also change its position here, I, to a different value. I can say ages of I equals a different number. You can modify that. Okay, but down here you can't, because you don't know the position in the array. So that is the one of the disadvantages of using for each. But of course, it's not to serve for that purpose. The purpose is just basically to iterate or loop through the entire array and either print everything out or do some type of comparison or some type of data manipulation for that value. Okay, so that is the difference between the for each and for next. And we'll do some more examples. This is passing array element. Just like you pass data before, okay, you can also pass array elements into another function or another subroutine. Okay, so because really all you're doing is basically you grab the value and then you pass that over to another function. So in this example here we have a subroutine here for a button click, and we declare a variable name of num that will store 21 numbers, right? 21. This is the upper bound, and then we'll say the fifth subscript with the sixth element here has the value of 10, and we want to pass this number 10 to this function here. So writing here triple and then num of 5. Okay, so it will actually calculate or process this first. So it looks at the num array, get the fifth index, the fifth sub element, which is 10 in this case, and will pass 10 to the function here. So it comes into x. X is really just 10, and it would do 3 times 10, return that 30 back to where it was being called here. So we're adding 30 to that list. Okay, so you want to add, you want to pass the element to a function or a subroutine. This is how you would do it. Okay, of course you can say, you know, x is equal to num of 5, and then you can just say triple x here. Same thing. Or you can just use the array and then reference that index to get the actual value and pass that along to the function. Okay, so you could pass the array element just like you would pass any numbers or any other string or any type. Again, we'll do examples of those as well. Function, we do a function. Remember, a function is a procedure that returns a data type, right? Returns a value. So typically when we did before, we say a function, you know, sum or get sum or something, and we put the paren here. If you have any parameters, we put that in there. If you don't, leave it blank, and then return as the data type. Okay, as integer, as string, as boolean, or whatever it is. Now you can also return back as an array of certain data type, and to do that, just basically as the data type here. If it's integer, you put int here. If it's string, you put string here, followed by the paren. Okay. So for example here, let's have an example here. Okay, let's see. Yeah, I'll do an example. It doesn't have one here, but we'll see an example. Okay, these are other built-in functions which let's see if there's an example in this somewhere. Yeah, I don't see it, so we'll do some examples. Okay, I will stop here, and then why don't we take a break, and then we'll come back in 10 minutes, and then we'll do some examples in Visual Studio. Okay, so I'll see you back in 10.